Okay, remember that a vector equation is going to give the exact same information as a pair of parametric equations, except the parametric equations here and here split x and y up into separate equations based on time, and the vector equation will simply put those two things together. So it's going to calculate the x and y position at the same time, and so you still need the same information. If you think about what's going on in each of these parametrics, that was my starting x value, and that's my rate of change for my x values. That's my starting y value, and that's my rate of change for my y values. So all that same information needs to show up in the vector equation. My starting value, so my starting location, had an x value of 2 and a y value of -1. And then every second, or every minute, or even if t just represents number of steps, every unit of time, I'm going to have a certain displacement or rate of change. And my x rate of change was -3, and my y rate of change was 2. Okay, so all the numbers will look exactly alike, just whether they're separated or together. Okay, and the reason that might come in handy is because the next thing that you were asked is, what is the velocity? And remember, velocity has to be a vector. So it's got to tell us actually several things. It has to tell us how far every unit of time, and it's got to give us a direction. I mean, it's got to be a vector, so it's got to have a magnitude and a direction. And that particular magnitude has to tell us how far we're going every second or every minute. Okay? So what that means is that it came in handy to write the vector equation, because the vector attached to t tells us just that. It tells us that every unit of time, that's why it's attached to t, we are going to displace 3 to the left and 2 up. So we know how far we're going, what direction we're going, and it's every unit of time, so it's a velocity. Okay, so the velocity vector, we would call that v usually, would be the vector -3, 2. And for some people it helps to actually write this vector equation form beforehand, because I think on the worksheet that we did with these problems on it, you went straight from the parametric form to the velocity, and I think people had trouble figuring out where the -3 and the 2 came from. So then the final part of that part of the question was to find the speed. Now remember, speed and velocity get mixed up because people think, oh, it's how fast I'm going. But speed doesn't have to include direction. So that means that all you care about is the size of your velocity. And another word for size is magnitude. So if I find the magnitude of that velocity, and remember, magnitude is just a fancy way of saying use the Pythagorean theorem with the components for your vector. So my velocity was the vector -3 and +2. Those are the legs of my right triangle, and I'm finding the hypotenuse. I'm finding the magnitude of that vector, and I get square root of 13. Okay, make sure you're careful with your arithmetic. I noticed there were people on the quiz who did things like this: -3 got squared and it stayed negative, or there was a subtraction in here when that's not going to happen ever. That kind of stuff. So just pay attention to your arithmetic. And then the Cartesian form. Okay, remember that that was in the notes on parametric equations. So 2 steps. Step 1, take your x equation and rearrange it to get t by itself. Now, I don't like negatives, so when I do this, I'm going to take the 3t and I'm going to move it over here, and I'm going to take the x and move it over here. But however you want to do that is fine. And then divide everything by 3. And there's a lot of ways you could write this. I know that on several of my answer keys, I've written this in this form instead, but you could write it as -1/3 x plus 2/3. I mean, however you want to write that. So any of those is fine, because it's not even your ultimate goal. Your ultimate goal is to then take that equation and plug it into the y equation. So you have y equals -1 plus 2, and now you have a formula for t. So t can get replaced. Okay? Now since I've gone ahead and I've gotten it, I'm going to go ahead and use the final version of the equation I just wrote. 2/3. Okay? And so y equals -1, and then the 2 would distribute through the parentheses, so I would have minus 2/3 x plus 4/3. And so I'm going to jump over here off to the edge. So then I would have y equals, and I would combine my like terms, and I would have y equals -2/3 x plus 1/3. But you notice that the problem said, I know it's covered up with my work now, but you notice it said that we wanted ours in standard form. So that means that we need to do some converting still. And that's why I altered the wording on this problem. So, I mean, this equation is perfectly fine if you're not told you have to write it in standard form, but you were. So standard form requires that it's in this format. So the first thing I need to do...
Standard form? I know what standard form is.
Very good, James. Okay, but I'm recording. Hold on. So that requires that x move over to this side, so I'm going to add the 2/3 x to move it over here. And it requires that there's no fractions, so I'm going to take everything in that equation and multiply through by 3. And so I get 2x plus 3y equals 1. And so there you go. There's your standard form. I mean, now this equation up here, it would still earn you the majority of the credit. You did by far the majority of the work, but you're just not putting your answer in the version that we're looking for. Okay? So as you can tell, my kids are getting out of the bath, so I'll resume recording in just a few minutes after they're ready for bed. Okay, so the final question related to this is when and where does it cross the line? And as some of you may remember, or if you're not in my class, you may have been told that I asked you when first, because that is the order in which it's the easiest to solve this question. Because if we know that we have essentially a finish line and some moving object is moving towards that finish line, running this direction for example, we know that if that moving object is going to cross that fixed line, that the x and y coordinates will have to be equal to each other. They've got to hit the same point. So that means that this x equation up here will have to be equal to this x variable down here. And the same thing's true of the y. So what we do is we take our x plus y equals 2 equation and we substitute x. So we take our x-parametric equation and we substitute y, -1 plus 2t. And what we've got is a single equation with just one unknown, just t. So that means that we can solve for t. So if I simplify the left side and I combine my like terms, because I had the 2 and the -1, so that's 1. And I had the minus 3t and the plus 2t, so I get minus t, and it's equal to 2. And so t is equal to -1. And negative time is okay. It just means that the runner crossed that finish line 1 second ago. Okay? And then the final part of that problem would be the where. And once you know the when, you can just take the parametric equations and plug in that time. And so this becomes a plus. And so you end up with 5. And then y equals -1 plus 2, and then we plug in that -1 as well, and we end up with -3. So this is when that person crossed the line, and this is where the person crossed that line. Okay, so a whole bunch of topics covered there. And then the second question, oh, I guess I'm going to go in reverse order, sorry. The second question was the spider and the fly problem. This is actually a problem that I just rewrote. It was on the scavenger hunt review. So it says, it's written as a word problem. A spider and a fly, they drop onto a table and they begin to crawl around the table. The spider drops onto the table at the point -2,5. So I'm going to write the x equation for the spider and the y equation for the spider. And the spider first drops onto the table at the point -2,5. So the spider's starting x is 2, the spider's starting y is 5. And the spider moves 2 units right each second, so plus 2t. And the spider moves 1 unit down each second, so minus 1t. Okay, that's the parametric equations for the spider. Okay, and then, let's switch colors here. It says that the fly drops onto the table at -4,2. So I'm going to write the parametric equations for the fly. And the starting x position for the fly was -4. The starting y position was 2. And it also moves 2 units right every second, so plus 2t. And it moves 1 unit up every second, so plus 1t. Okay? And then it says, determine algebraically if their paths cross, and if so, where. So what a lot of people want to do is they want to pull out their graphing calculator, and they want to graph these. You can do that to check your work, but remember that you have to be in the right mode, you have to have the window set just right, you have to make the graphs look different. I mean, just all kinds of stuff has to be messed with. So that's one of the reasons, one of the many reasons we tell you you have to determine algebraically if they cross. So, as usual, there's a variety of ways to do this, but this is how we would usually do it. I'm going to take each bug's equation and I'm going to put it in Cartesian form. So here's my spider. Okay, so I'm going to take the x equation and I'm going to rearrange it to get t by itself. So t is equal to 1/2 x plus 1. Okay, and I plug it into the y equation. So y equals 5 minus, though I don't have to write the 1, and then the 1/2 x plus 1 goes in there for t. And so the spider's Cartesian equation is -1/2 x plus 4. Okay, then I do the same thing for the fly. So I take the fly's x equation, x plus 4 equals 2t, and I get t by itself, so 1/2 x plus 2 this time. And I plug it into the y equation. So remember, this was the y for the spider, this is the y equation for the fly. And I have 2 plus, and then once again I don't have to write that 1 right there, and then I put the t in, 1/2 x plus 2. And so the fly's Cartesian equation is 1/2 x plus 4. And if I want to know if those two lines cross each other, I simply set them equal to each other. So -1/2 x plus 4 is equal to +1/2 x plus 4, and so x is equal to 0. Okay, now it doesn't mean there's no solution. That means the x-coordinate of the point where their paths cross is 0. And then to find the y-coordinate, I plug it into either one of their equations, and I get a y-coordinate of 4. So yes, their paths cross. Their Cartesian equations did intersect each other, and they intersected each other at 0, 4. Okay, now remember what that tells me. That tells me that both of those bugs, or whatever you want to identify them as, go through that point. So I now know that. So when I want to know if they meet, I just need to know when they're each at that point. So for each of them, for the spider and for the fly, I simply choose one of their equations and set it equal to the correct coordinate. So let's say I took the spider's y equation. The spider's y equation was 5 minus t, right? And I want to know when is it going to be equal to the y coordinate of 4. And so I add the t to move it over here and subtract the 4 to move it over here, and I get time equals 1. So that's when the spider is at that point. If you solved the x equation, it's not necessary, but watch what happens. You take the x equation, you want to know when it's equal to 0, because that's the correct x coordinate, and you get 2t is equal to 2. So sure enough, what are you going to get? You're going to get t equals 1. So you don't have to do it for both equations, because you're going to get the same answer either way. But then you need to see when the fly is going to be there. So I'm going to take the y's fly equation, 2 plus t, and I'm going to see when it's equal to that coordinate of 4, because that's the y coordinate, remember? And I get t is equal to 2. So that's when the fly is there. So, no, the spider and the fly do not meet at the point of intersection. Their paths may cross, but the spider is there 1 second before the fly, so the spider doesn't catch the fly. Okay, so I hope this helps. These were some of the more intensive problems. The rest of it is all just like the quiz. So make sure you go over that quiz that you hopefully got back today from all of your teachers, and come into tutoring tomorrow morning or tomorrow during Flex if you need it.